In this learning, we will talk about percentile values. So, percentile values is where SPSS computes all the percentiles, and it also computes quartiles and something known as cut points. So we will start our discussion with quartiles. I have this data file open, quartiles underscore percentiles .sav, and we are in the variable view of this data file, and we have this variable named electricity usage in some sort of units, and it is a numeric variable with scale measure. Let us go to the data view, and in data view we see that electricity usage is given, and first of all we will start with calculation of quartiles. But we can see here that the data is not sorted. It is not ordered, or we can say arranged in ascending or descending order. So first of all, we have to arrange the data. To sort the data or arrange the data, we go into data, sort cases. I will take electricity usage into the variable to be sorted. I am still keeping sort order as ascending, and I click OK, and SPSS has sorted these variables. Now these are in ascending order, and we have 20 cases starting from 33 to 61. Now what quartile basically do? Quartile divides the series into 4 equal parts. So here this series quartiles will divide it into 4 equal parts. So this will be Q1, and this will be Q2, and this will be Q3. So series gets divided into 4 equal parts with quartiles, assuming that these are 4 equal parts. Now Q1 is what? Q1 is nothing else but it is equal to the size of n plus 1 over 4th item. So in this series there are 20 values, right? So there are 20 cases. So Q1 will be of the size of 20 plus 1 over 4 item, which is equal to 5.25th item. Now we know that 5th item is 40. So these are the items all the way up to 20. So 5th item is 40. So it would be 5th item plus 2.5 of difference between 5th item and 6th item, which is 43 minus 40. So this way we get the value 40 plus 0.25 of 3, and here we get Q1 as 40 plus 0.75 units. So this is Q1. Q1 is 40.75 units of electricity usage. So this way SPSS can do these calculations without actually arranging the data in ascending order, and without actually going into these formulas. So SPSS can quickly calculate these values for us. Q3, as we said, is Q3 is nothing else but equal to size of n plus 1 over 4 times 3. Since it is the third quartile, so it will be equal to the size of 20 plus 1 times 3 divided by 4 equal to the size of, I would say, 15.7 fifth item. And if we look into the series, 15th item is 51, this one, or this one, let us see, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is 15th item. So 15th item is 51 plus 0.75 of difference between 15th item and 16th item, which is 53 minus 51, and approximately I would say this is approximately 3, I would say. So Q3 is 54. So value of Q3 is approximately 54 here. So this is the concept of quartiles. So quartiles divide the series into 4 equal parts, and since these are 4 parts, therefore Q1 and Q3 are the important values, as Q2 is nothing else but median of the series. It is important, but it is already calculated as median of the series. So here, that's why we have not shown its calculation here. Now let us use SPSS to compute the values of quartiles. Although we have arranged the data in ascending order, but we were not required to do so for SPSS. We did it for manual calculation, but still it is okay. We will go to analyze descriptive statistics, frequencies, and I will reset the variable, take it as one of the variables, and in statistics I will pick quartiles. I click continue, and then I click OK in this screen, and here SPSS has computed 4 quartiles, because for the quartiles Q1 is nothing else but, so SPSS has quickly calculated these values for us. And if we look here, the values are expressed in terms of percentiles. So this is 25th percentile. So 25th percentile is nothing else but Q1, and 75th percentile is nothing else but Q3, and 50th percentile is nothing else but Q2, or which is also median of the distribution. So we, when manually calculated, sorry about that, we approximated Q3 to 54, whereas it was not 54, it is 52.50. So this way SPSS computes the quartiles and percentiles, and we need to understand the concept only. The concept is, as I will say again, so quartiles divide the series into 4 equal parts, and therefore are called Q1, Q2, Q3, and although they don't show like equal to, I can't represent them like equally, but the concept is that these should be the equal parts. Similarly, percentile divide the series into 100 100 equal parts, right? So this way we can compute any percentile So we can compute the 75th percentile, which has been computed by SPSS here, and we can also compute 60th percentile. Okay, 60th percentile would be what? It would be equal to the size of 0.60 into n plus 1 items, nothing else. So it would be equal to the size of 0.60 into 20 plus 1 item. So this way we can calculate the value of P60th. To compute P60th, I will go to Analyze, Descriptive Statistics, Frequencies, and SPSS has remembered our variable choice from last time. I will go to Statistics, and this time I will pick percentile, and here I will type 60th percentile 60 and press enter over here. And I will add here, and I will click continue. I will click OK, and P60th is 49.20. So it means that this is the 60th value. This is the 60th value when series is divided into equal 60 parts. So when series is divided into equal 60 parts, equal 100 parts, 100 equal parts, if series is divided like that, then the 60th part is P60 and its value is 49.20. And as we were saying last time, this value is equal to the size of 0.60 into n plus 1 item. Now SPSS can compute quartiles, SPSS can compute percentiles, but what if we want to divide the series into say suppose 8 equal parts or 7 equal parts? How we will do that? In order to do that, we will go to descriptive statistics, frequencies, and this time I will use cut points. Here I am dividing the total series into say 7 equal parts, which are known as septiles. So if we want to divide the series into 7 equal parts, then SPSS has done that, so that the series is divided into 7 equal parts: Q1, Q2, Q3, Q4, or if you want to call it septiles, then S1, S2, S3, S4, S5, S6. So let's assume that this value is like this, right? So this divides the series into 7 equal parts, septiles: 1, 2, 3, 4, 5, 6, 7. So there will be S6, right? So this percentile, which is 14th .285711429, is nothing else but first septile. So this is first septile, this is second septile, third septile, fourth septile, fifth septile, and sixth septile. So septiles divide the series into 7 equal parts. So similarly, you can compute octiles, which divide the series into 8 equal parts using the cut points. Similarly, you can compute deciles. Deciles divide the series into 10 equal parts. Right. So although these measures like octiles and deciles and septiles are rarely used and probably you might not have heard about them, but the thing is SPSS very easily does that job for you. So and this job is done via using the cut points method.